Welcome. Today, we're diving into an absolutely critical industrial procedure, hydrostatic testing. We're going to go way beyond just ticking boxes on a form to really understand the professional protocol. How to do these tests the right way, safely, and get results you can actually stand behind. Let's get started. Okay, let's kick things off with a really important shift in mindset. It's so easy to see a hydrotest as just another piece of paperwork to get through. But this quote right here, it nails it. This is a highly controlled technical operation. If your prep work is sloppy, the risk just shoots through the roof. And that final piece of paper, it's completely worthless. The stakes are really, really high. So if it's not just a form to fill out, what are we really trying to do here? Let's break down the actual purpose of this whole thing. A hydrotest really has two main jobs. First, we need to prove the mechanical strength of the equipment. Can it physically handle the pressure it was designed for? That's question number one. And second, we need to confirm its overall integrity and tightness. When you get it up to test pressure, does the whole thing hold together without a single leak? So you see, it's a test of both its muscle and its seal. Now here's the thing, and this is so important. The success or failure of the entire test is pretty much always decided right here, in the preparation phase. This is long before you even think about applying a single pound of pressure. First step, it's all about setting boundaries. You have to, and I mean have to, properly isolate the piece of equipment you're testing. That means using the right blinds, flanges, and valves to create a very clear test perimeter. This makes sure that no other part of the plant gets pressurized by accident. Step two is all about your instruments. Look, your data is only ever as good as your tools. This one is completely non-negotiable. Your pressure gauges have to be calibrated, they've got to have a measurement range that makes sense for your test pressure, and you need to put them somewhere they can be read clearly and safely. And step three, fill and vent. You've got to get the system completely full of your test medium, which is usually water. Now, as you're filling it, it is absolutely essential that you get all of the air out. You've got to pay really close attention to any high points in the piping, where those little air pockets love to hide. And this is exactly why venting is such a critical safety step. Let's be crystal clear about this. Water, well, it's basically incompressible. Air, on the other hand, is not. So any trapped air inside a pressurized system becomes a pocket of stored energy. And if something fails, that energy gets released, suddenly and very, very dangerously. All right, once our prep is done and we've double-checked everything, we can finally move into the execution phase. And the single most important word from here on out is control. A professional test is never, ever rushed. You bring the pressure up in controlled, pre-planned steps, sometimes called paliers. At each step, you hit pause. You let the pressure stabilize, and you watch the equipment. This is your chance to carefully inspect for any leaks, especially around temporary fittings. Once you hit that final test pressure, you hold it for the required amount of time. And, just as important, you bring the pressure back down gradually when the test is over. Okay, so we've seen the right way to prep and execute a test. Now let's talk about what can go wrong. Because honestly, understanding these common mistakes is the best way to make sure you never make them. So here are some of the biggest slip-ups we see out in the field. Number one, just pressurizing way too fast, ignoring those controlled steps. Number two, using a gauge that's not calibrated or is the wrong range, which basically makes your readings totally useless. Number three, and we talked about this, failing to get all the air out, a huge safety risk. And finally, using flimsy or badly secured temporary connections that just can't take the pressure. Let's just be real about what happens when this goes wrong. A poorly done test isn't just worthless data. It creates a genuinely dangerous situation for every single person in the area. Safety is never, ever optional. So how do we make sure we're always operating at the highest level? Let's switch gears from what not to do to how to truly master the professional standard. The professional approach, it always starts with discipline. You've got to have a written procedure for the test, and you absolutely must use a checklist. A checklist makes sure that no critical step, from checking your instruments to venting the system, ever gets forgotten. It's really your best defense against simple human error. And this is what it all leads to. The ultimate goal isn't just to do the test, it's to prove the test was done right. Your final deliverable is a clear, complete, and signed test report. This document, with all its pressures, times, and signatures, is your objective, defensible proof that the equipment is sound. All right, let's make sure these ideas really stick. Time for a quick knowledge check. You ready? First question for you. Why is trapped air so dangerous? Well, think back. Unlike water, air is compressible, right? That means it stores a huge amount of energy when it's pressurized, and that energy can be released violently if something goes wrong. Okay, next one. What is the most important quality of your pressure gauge? The key is that it has to be properly calibrated, with the paperwork to prove it, and its range has to be right for the test pressure you're trying to hit. And for our last question, this one's a big one. What is the difference between doing the test and proving the test? Doing the test is just the physical act, putting pressure on the system. But proving the test, that's having the meticulous, signed-off documentation that makes the whole thing valid, traceable, and defensible. So, if you remember one thing, remember this. The entire professional protocol can really be boiled down to a simple equation. A successful hydrostatic test equals a clear objective, plus meticulous preparation, plus absolute control, plus ironclad proof through documentation. And that's a wrap on our explainer on the hydrostatic testing protocol. Remember, the value of your test is only as good as the process you follow. Be sure to join us for our next explainer, where we'll build on all this and take a look at the best practices for leak testing. We'll see you then.